Hey everyone, Mr. H here. We're going to jump right into section 5.2, which is on the basic definitions of the six trigonometric functions. They're based off of this picture of an angle in standard position. So let's just say it's in quadrant 2, but it doesn't matter. It could be in any quadrant. Um, then we have a terminal side, right? This angle here going through a point xy. And then if you think about what the value of y is, it's the distance to that point down to the x-axis, right? Almost like the height of a triangle. The x is the distance along the x-axis, and the r is what we're going to use to call the hypotenuse. Okay. If we want to come up with an equation for r, we can use Pythagorean theorem, right? The old a squared plus b squared equals c squared. Let's write it like this though. R squared equals x squared plus y squared. Okay, the hypotenuse squared is each of the sides squared added together. And then if I take the square root of both sides, that's where that formula comes from. So anytime you need to find r, you can just use that formula, okay? And now here are the six trigonometric functions. So let's look at that first one. I put in quotes how you say it or what the word is, whereas in the equations, you'll see an abbreviation. Okay, so the first one, sine theta is equal to y divided by r. That's sort of an input-output type of function thing, right? It's saying that the sine of the specific angle is defined to be the ratio of the y side divided by the r side. Okay, so the y over r is going to change depending on the size of the angle. So it is important to have that theta there defining the ratio. Okay, so there's six of them. We have sine, cosine, tangent, and then the bottom three are cosecant, secant, cotangent. Notice those three are just the top three flipped over. Okay, so let's practice with those definitions with some examples. Number one says the terminal side of angle theta goes through the point 2, 3, find r and find sine theta. Okay, so I want to draw that out. 2 comma 3 is in quadrant 1, right? Over 2, up 3. There would be the point 2, 3 right there. Okay, now think about this as making a triangle. So there, that side is the y value, that's 3. This side is the x value, and that's 2. And if I want to find r, which is here, I can use that formula above, which is basically Pythagorean theorem, right? R is equal to the square root of 2 squared plus 3 squared. All right, that's equal to the square root of 4 plus 9. And then 4 plus 9 is 13. Square root of 13 is the value for r. Okay, how about part B? Find sine theta. Remember, theta is just this angle here. It doesn't matter what it is right now. We're just wanting to find the sine of it, right? So sine theta, by the definition, is y divided by r. And now I know those values. The y is 3, and the r is, we just found it, the square root of 13. And then it does say we rationalize all denominators. So to do that, I'm going to multiply the top and the bottom by a square root of 13, which we used to do in algebra. Okay, and that rationalize just means we shouldn't have a square root in the denominator. All right, so the top is 3 root 13, and the denominator root 13 times root 13 is 13. Okay, so that's how those work. Let's practice some more. Here's another one. The point negative 3, 4. So the x is negative 3, the y is 4. The first thing you're going to want to do is find r. Right, so let's pull this up a little bit, make it look nice. R is the square root of -3 squared plus 4 squared. Right? And -3 squared is +9. 4 squared is 16. So that's 25 if I add them together, and that's a perfect square, 5. Now you know x, y, and r, and so to find all 6, you just apply the definition of each one. So sine theta is y divided by r. Y is 4 from that point, and r is 5, and we just found it, and that's reduced and rationalized, and we're good to go. Cosine theta is x over r. X is -3 and r is 5. And then typically what you do with that is you just put the negative out front as opposed to on the 3. It's the whole fraction is negative. Okay. Tangent theta, just keep on going, is y divided by x. Y is 4, x is -3. Pop that negative out front, -4/3. This one's nice because there's no square roots, no rationalizing needed. Okay, the other 3, just flip those over, right? So the one that goes with sine is cosecant. Cosecant is r over y, so 5 over 4. Secant is r over x, so 5 over -3, but I'm just going to put the negative out front. And then cotangent is x over y, so just flip that one over. 3 on the top, 4 on the bottom, negative out front. And there's your 6 trig functions of that angle that goes to that point. Okay, let's try another one. This one we're probably going to have some rationalizing to do, but now we get the idea, right? First thing is find that r. R is x squared plus y squared, 2 squared, plus -1 squared. That's 4 plus 1, square root of 5. All right. Let's start knocking them out. Sine theta, y divided by r. Y is -1, r is square root of 5. Rationalizing that, got to multiply by square root of 5 over square root of 5. Okay. And that's going to be, so negative out front, square root of 5 over 5. -5 over 5. Circle it. It's got to be right. Cosine. Cosine theta, x over r. X is 2, r square root of 5. Rationalizing the same way, multiplying by a √5 over 5, 2 √5 over 5. Tangent theta, y over x. Y is -1, x is 2. So that's just a -1/2. Okay, flip all of those over, and we've got this. What happened there? Cosecant theta. We're just going to do r over y, which is √5 over -1. And that's -√5. Okay. Secant theta, root is r over x, √5 over 2. Finally, cotangent theta. Flip that one over, 2 over 1, -1, that's just -2. Okay, we're cruising, we got this. Stick to those definitions and you'll be fine. Okay. One more. This one is what's called a quadrantal angle because it goes to the point 0, -1, kind of on the y-axis, right? Below the x-axis on the y-axis, but doesn't matter where it is. Just do your equations. Sorry, what's going on here? My hand's sweaty, won't work. Okay. R is x squared, 0 squared plus -1 squared. Right? X squared plus y squared. So that's 0 plus 1. Square root of 1, which is 1. All right. And then here we go. Sine theta equals y over r. Y is -1, r is 1. That reduces to -1. Cosine theta, x over r. X is 0, r is 1. That reduces to 0. Tangent theta, y divided by x. Y is -1, x is 0. Whoa! So if you get 0 in the denominator, if you remember that from algebra, that's undefined. Cannot divide by 0. So just write that, right? This would equal undefined. And that's the answer. Just got to write a word for those. So anytime you end up with a 0 in the denominator, which will happen if you have these quadrantal examples, just write the word undefined and you're good to go, okay? Finally, the last three, cosecant theta is the reciprocal, so 1 over -1, still just -1. Secant theta, the reciprocal of cosine, 1 over 0, right? I'm just flipping over the cosecant. So oops, we get another undefined. And then finally, cotangent theta. Flip over the tangent, that's 0 over -1. That's fine, 0 up top, just gonna reduce to 0. Okay, and that's it. All right, so those are the 6 trig functions, starting just to get used to those definitions, writing the ratios based off of a point. And then we'll stop there. We'll do some more in the next video. Hope all is well. Send questions my way if you have any. Talk to you later.